in organic chemistry, in the introduction, you need to teach a student about homologous series, the characteristics, like they have the same functional groups, or the members of the same homologous series have similar chemical reactions and stuff like that. And the functional groups that you need to teach them include alkanes, alkenes, alcohols, halogenoalkanes, carboxylic acid, aldehydes, ketones, amines, amides, esters, nitrile. Okay. So for standard level, they need to be able to name and draw the structures for these 7 functional groups. For the high level, they need to draw the structure and name these 4 additional functional groups. Okay, they need to be able to apply or deduce the IUPAC naming for up to 6 carbon in a chain. Okay, so it's structural and IUPAC naming for all compounds containing all these functional groups, up till here for standard level and up till here for higher level. Okay, then they need to learn about isomerism. So there are 2 types, structural, that they need to learn, structural and stereoisomerism. Okay, and structural, there are 3 different types, positional, carbon chain, and functional group isomers. Okay, while stereoisomers, there are 2, geometric and optical. Okay, so the standard level students need only to learn about the structural isomerisms, while the higher level students need to learn about stereoisomerisms also. So out of the functional groups that we talked about at the introduction, we're going to zoom into just 4: alkanes, alkenes, alcohols, and halogenoalkanes. Okay. Other than describing the characteristics of each, like alkanes is a saturated hydrocarbon, alkenes have at least 1 CC double bond, alcohols has OH, and halogenoalkanes has a halide attached in the alkane. You also need to explain about the specific reactions that they undergo. Okay, so for example, alkanes. In alkanes, when we're teaching about alkanes, you need to talk about free radical substitution. Okay, so they need to know the reagents, which are the halogens, and of course the alkane, and then the condition, which is UV light. Okay, and for free radical substitution, you need to teach your students about the mechanism. Okay, how it happens. So you know that there will be initiation, propagation, and termination. And you should mention also about homolytic fission and heterolytic fission. Okay, that's for alkene. For alkenes, we are going to be talking about addition reaction. Okay, so Also, you need the reagents and conditions, but there's so many things that can be added across the double bonds in the alkene. So you need to include addition of steam, addition of hydrogen halides, okay, can be bromine, chlorine, fluorine, iodine, and addition of halogens itself, okay. Also here, you need to be talking about addition polymerization, in which you should mention about monomers and how from the structure of the alkene you can deduce the repeat unit, and giving the structure of the polymer itself. Okay, addition polymerization. In alcohols, you need to be talking about oxidation and how primary, secondary, and tertiary alcohols will all give different products under the same reagent of acidified potassium dichromate. Okay, you also need to mention about the difference between reflux, setup, and distill. Like for example, how in primary alcohol you can get either aldehyde or carboxylic acid depending on how you set up the reaction. Also, how this reaction can be used to distinguish primary, secondary, and tertiary alcohol. For example, if you have an unknown solution of an alcohol, you know it's an alcohol but you do not know it's primary, secondary, and tertiary, how can this reaction be used to differentiate them? Okay? Now, halogenoalkenes is one of the biggest or one of the functional groups that the students study more deeply. Okay, for the standard level, okay, all these are the same for standard and higher level, but for halogenoalkenes, for the standard level, they only need to distinguish primary, secondary, and tertiary, and which one of them will undergo nucleophilic substitution. Okay, so the reaction that we are going to be talking about here will be nucleophilic substitution. Okay, so both mechanism, SN1 and SN2, the students need to know. And like for example, SN1 is only happening for third and second, or rather is more favored for tertiary and secondary, and SN2 is more favored for primary and secondary. And most importantly, you need to know the mechanisms for both SN1 and SN2 nucleophilic substitution reaction. Okay. Now for the higher level, there are more things that need to be studied. In standard level, the only nucleophile that you need to be concerned about is OH minus. But in higher level, you need to also add about CN. You need to also add CN minus and amine. Oh, ammonium, okay, as nucleophiles. Also, in higher level, you need to be discussing the relative rates of nucleophilic substitution reaction. And the factors that affect them. Namely, the type of halogens attached to your halogenoalkane and the strength of nucleophile. So that will affect the rate of reactions. Also, you need to explain why tertiary halogenoalkane prefers SN1 a mechanism. Okay. And from here, okay, so we know that when you use alcohol, when you use OH minus, you will get alcohol after nucleophilic substitution of halogenoalkane, and when you use CN minus, you will get nitrile, and if you use this one, you will get an amine. Okay, so you need to also explain to your student, through hydrogenation reaction, your nitrile can be converted to amine. Okay. So that's some of the things that you need to teach your student. And one additional reaction in halogenal alkenes that a high level students need to know will be elimination reactions. Okay, here we need to emphasize that for nucleophilic substitution and elimination reactions, you are actually using very similar reagents. So you need to teach your student which one will favor substitution and which one will favor elimination. For example, both will require the presence of OH minus, but elimination will happen if the medium is alcoholic, while in nucleophilic substitution, the medium is aqueous. So your students need to know all these conditions. Okay, and the last condensation reactions are only applicable to your higher level students. So here you need to teach them about esterification, okay, and so the reaction and how to name esters, okay, and the last one will be condensation, polymerization. So in condensation polymerization specifically, you need to talk about two types of condensation polymers, polyamide and polyester. Okay, and how you can form this. Okay, so you need also to make reference to addition polymerization and what are the characters of your monomers that allows for addition polymerization or condensation polymerization.